This is called JDK 19 Virtual Threads. And what we're going to be doing is talking about JDK virtual threads and how they came about, what they are, how you can use them in your applications today, and also a bit of some history about how we got to where we are today. Okay. So he said the important things about me. I've been working with Java for a long time. I wrote a book a long time ago. If you like podcasts, you should check out the Stacked podcast, which is not on that site. Oh, yes, there it is. That's stackedpodcast.com, where we talk about Java, just back-end development, front-end development, general software development issues. And my co-host on that is Daniel Inahosa. Who had a few talks here this week as well. And we have lots of interested people on that show. So you should check it out if you like podcasts. And let's see what else is interesting here. In addition to being a Java champion and working with different technologies and running Virtual, doing consulting, I am also the project lead for the Eclipse documentation for Jakarta EE. So I'm very involved with Jakarta EE and microprofile and all these sort of specifications. So, all right, so that's enough about me. I'm not going to handle from the audience. So how many people are working with virtual threads today? Okay, good. So it's probably not the right session for you if you're already using them, so that's good. How many people work with Spring Boot? Okay. How many people work with Quarkus or some other microservice framework? Okay. Micronaut. Wow, a Micronaut person. Okay. So we got Micronaut and a Quarkus person, I think. Yeah. All right. Cool. Two Quarkus people. All right. How many people work with some other micros or service framework, whether it's like an old app server or something custom? How many people work with something that's something that doesn't actually require, like something that's not actually a framework, basically some custom written code where you actually need to handle the threads yourself? Anybody? Okay. All right. Good to know. So I want to start with a journey. And you may be able to tell I'm not the youngest person in the world. So now when I look at most technologies and most things, I look at them in sort of a historical context. So I'm going to take you back to 1997. So this was were the very early days of Java. I was actually I had graduated university by then, but I played with it recently. I thought it was cool and hip. And there was this cool thing they had called JDK Green Threads. This was in JDK 1.1. And this was like some hip thing that they added. And when they did it, it was the only thread model available. So we still have like, the thread API, the sort of basic constructs you're used to today, right? But you could actually create a new thread object and it would map, it would basically be a green thread, which would map to a single thread. Because back then, most CPUs were like one core, right? So if you wanted to approximate the ability to have multiple threads, they sort of had to be green threads, right? So in those years, we had green threads. I think they were mostly on Solaris and Linux Unix variation, not so much in Windows back then. But basically, just as virtual threads do today, the JVM managed the execution of those threads. But the limitation was that they were basically built for single-threaded machines, right? So JVM ran as a single thread. And of course, because of that, if you had a thread that was blocked on some I/O, it would then block all the processes, right? Because there's only one thread. Even though you had a whole bunch of green threads, like there's really only one real thread. So if you block something with your green thread, it would block the entire application. So we had green threads back then. But, after a few years, we started getting better processors, right? They had multiple cores. So over time, just a few years, they phased out green threads and went to platform threads, which is what we've known for the last 20 years, right? 20 something years, which is where one thread that you create in Java maps to one thread on the operating system, which is what they call a platform thread. And if you're curious about green threads, Wikipedia has a nice little entry about it. So 2000 to current, we have like I said before, platform threads. Each Java thread maps to an OS thread, and this is what we call one-to-one schedule. Basically, create a thread, you give it to the OS creates a thread. And this is, pretty simple to understand, makes logical. It's easy from a JVM perspective because you're basically just doing a one-to-one mapping. And the reality, though, is you end up in situations with this model where people block a lot. So I picked this picture, and then I realized I was doing this conference to a lot of people who don't watch American football. So if you're not familiar with this, in American football, it's the guy on the left here. There, he's the quarterback. He's going to throw the ball, right? And these guys in front, their job is to make sure nobody. No, this is green. Doesn't show up very well. These guys over here, their job is to make sure nobody gets to the quarterback, right? So they're essentially blocking, and they actually call it blocking. So they're blocking the people coming at the quarterback. And if you think about it, that's a lot of what we end up doing, because anytime we have an IO operation or something, we end up blocking, right? And because we have a one-to-one mapping of platform thread, we block the platform thread. So if you have lots of IO operations, you end up having throughput issues, right? Okay. So if we take a look at sort of the evolution of server-based applications, we came out with the Servlet API initially, right? And Servlet API was great because it allowed us as Java developers to integrate with web requests, with web servers, get a web request, return a web response, right? But the thing was, it was a synchronous operation, and a blocking operation in the sense that you get a thread to handle your request, but then you're basically hogging that platform thread, right? So if you do something that's expensive, it'll take a long time. But that's basically how we built things. We had Tomcat. How many people have used Tomcat? Yep, super popular. Jetty. How many people use Spring Boot? Do you know if you use Tomcat or Jetty? Or Netty? Which one? Yeah, Netty, you're right. So we'll get to Netty later. So, all right. So we had that. And if you had an IO operation, we block. And the same thing goes for the Apache web server. So, how many people remember Apache? Oh, not that many. Wow. Okay. So the Apache web server at one point had like over 80% of the market share for web servers on the internet. It was dominant. And that was the way things were. And, that's fine. It worked great for a long time. But what happened is, the internet got a lot bigger. So we talked about like 97, 2000. So over time, people were like, I feel like we should be able to support more requests, right? So around 2004, 20 years ago, Nginx came out. How many people have heard of Nginx? Okay, so a few more of you. So Nginx now has the majority of the market share, like Unify. So the major difference with Nginx was that they wanted, well, number one, the main design goal was that they wanted to control the C10K problem, which is the scalability issue that prevents Apache from getting more than 10,000 frequent requests. And they solved this by using an event-based approach for handling requests. Okay, this is basically what we've come to know in all of these reactive non-blocking servers. Is they basically have an event-based approach where they basically manage the thread process, right? So they take your task, they assign them the platform threads, and whenever there's a blocking, they reassign some other tasks to that platform thread, essentially. And because of this, Nginx scales better. And around 2004, Netty came out as well. Same sort of idea, but from a Java perspective. Node didn't do this until 2009. This is another benefit of Node. That's part of why people like it, because it's performant, because it uses the event loop approach. Then we had Akka. You heard of Akka before? What? There are a few of you. Okay. So Akka does this as well. 2010. Vertex is sort of a layer on top of Neti. That came out in 2011. And if you remember, we just talked about Servlet, right, with Jetty and Tomcat. They actually added async support in 2013 in Java EE7. And that's why you can do reactive stuff with Jetty and Tomcat if you want to. And Jakarta REST, which is Jakarta REST now, which is actually available in Spring, although people often don't use it in Spring app, that now supports async as well. So basically, it took about 10 years, but everybody now finally realizes, hey, we should have the ability to do stuff where we don't map your request directly to a platform thread, right? All right, so we talked about everybody async, and let me get one slide notes about. All right. So then we had the Reactive Manifesto in 2014, right? And this is sort of the genesis of a lot of the Reactive APIs that we've used over the last several years. But if you want to read about it, it's there. It's it's a good read. There's a lot of stuff there, but it's a good sort of way to get a handle on sort of the APIs that are in the Reactive space. Basically, the idea was like, if we're going to build massively scalable or very scalable systems, we want them to be reliable, elastic, message responsive, right? So they have to, of course, respond. The idea is rapid and consistent response times. We want them to be resilient, so they stay responsive in a state of failure. So even if parts of the system fail, it can respond quickly. Elastic, of course, means that it can be responsive even with increasing workloads. And a big tenet of this is message-driven, right? So we basically send messages throughout the app and then respond. And this also works just in general with enterprise systems, right? You do want, messages, elasticity, all that kind of stuff works, not just from a single microservice or a single service, but all the way through the entire system. So after the Reactive Manifesto, and actually even around that time, we got some APIs, right? So we got ReactiveX, actually came from Microsoft. And this is where RxJS, RxJava, all of these Reactive APIs came from. And of course, we have Spring Project Reactor, which is used in Webflux, and Reactive Streams in 2015. This is actually part of, it is actually an interface that actually is part of pure Java. So Java 9 and higher has streams built, the Reactive Stream built into it. Small Wire Mutiny, which is used by Quarkus as well. So all this came out with their cool Reactive APIs. And those of you who have done Reactive are familiar with those concepts, but for those of you who haven't, there's a few different concepts in all the Reactive APIs. There's observer and observable. And in Quarkus land in Spring, they're called Flux and Multi. But an observer is basically something that observes events, and observable is something that can be observed. So basically, you send events, and an observer will observe them. And that's basically sort of a streaming API. And then once you've got a whole bunch of events coming in, right, and your observer is listening to them, you can form operations, like all the streaming operations we're used to seeing, like map, flat map, buffer, filter, etc. There's also, instead of having an observable, you can also have a single, which is just basically one event, one value instead of multiple values. And there's also a subject, which is basically, it's only available in some Reactive implementations, but it's basically sort of like a proxy that's both an observer and an observable. So it's kind of a special case. There's a scheduler because, of course, you guys schedule all these events coming in, right? And all that kind of fun stuff. So those are just some of the basic concepts. And then if you're going to write a service and you want to use reactive APIs, you need to do that, right? So you need to have some way to integrate the reactive, like RxJS or Spring Project or Reactive or whatever into your framework, right? So Quarkus has a reactive set of APIs. Spring Boot does it with Webflux. You can also just use Vertex or Micronaut as well. And we all have support for these APIs. And what's interesting is that if you look at sort of the way you build things, I think this is actually a very good indication. This is actually from the Spring site. And the Quarkus has something similar. A lot of different frameworks have something similar. So basically you have the idea where you have you have like the reactive side. And again, my bar doesn't really work too well here. So you have the reactive side, and then you have the non-reactive side, right? You notice that they have for the servlet container, or you can use Netty. You can also use servlet because, as I said before, servlet does support async, right? And on the right-hand side, you just use servlet. You use reactive stream adapters. You don't really use the servlet API directly. You use Spring Security Reactive, Spring Webflux, and then Spring Data Reactive Repositories. Otherwise, you use Spring Data Repository. Right. So one of the things you may notice here is that, when you go reactive, you sort of go reactive, right? It kind of like changes your choice of the libraries you can use in the way that you do this. Okay. Good. So this is an example of a reactive service with Spring Webflux. And basically, you see here, we've got a normal REST controller. All this stuff is pretty normal Spring. But then down here, you see we've got this flux. And the flux is a single item being returned, right? And then we basically do some operations here. We do a flat mac and some other operations, and we get something back. So this is going to get everything. And the key thing here is that we're returning a flux or a multi, whatever the case may be, right? But we're returning a reactive type. Okay. And in other than that, there's not a whole lot special we have to do. Okay. Of course, now, whatever happens in here, you're going to have to use reactive APIs all the way down, right? But basically the idea. Quarkus is pretty similar. So Quarkus, you see it's a normal, and actually this is an example from our real app. I think I skipped over the slide, but I'm working on an app to help frequent speakers handle sessions. Very exciting, right? But anyways, so this is from we're using GraphQL. And you see here, we're returning a uni, which is, again, a single item in string, right? And because of the GraphQL stuff, we have a situation here where we're returning a uni, and the uni is a list of the actual type. And then, of course, these operations, you need to be using reactive APIs. So even if you like, GPA, on Hibernate, there is a Hibernate reactive that you would use instead. So reactive is great, right? And it does really well if you have the time and attention to go through and build all the code, right? And also, if you really need it, because not every particular, not every application. Okay, I'm not sure what just changed. Okay, you're good? All right. I'm not, assuming you actually need that level of scalability, and maybe worth it. But the reality is, like many things, the more reactive, the more problems you get. So the first problem with reactive is that it's kind of hard to read. So here's an example of some reactive code. And this is actually, again, some real code from a speaker track code base. And I look at this and I'm like, okay, I can read it, but it takes a little bit of effort. It's not like I can look at it and magically know what it says. There's a lot of stuff going on here. There's a lot of, chains and calls and maps and stuff. It's like, okay, so in order to read this, I need to sit down and think about it, which is okay. But you multiply that times your entire code base, it means that every single time someone needs to look at it, it's going to be harder for them to read. Now, of course, they could use a chat GPT or Copilot to explain the code. but I still don't trust them quite yet. So if you're curious about that, session about those tomorrow. So they might make up something, I don't know. Anyways, so that's one of the issues. The other one is that the stack traces are hard to read. So this is another actual stack trace from that application. And all it is, it's a validation error, right? I think I specifically put it a null somewhere to see what would happen, right? So did that. And then I looked at the stack trace and I'm like, okay, so this is our code, which basically is used to ensure that the GraphQL API returns the right exception, okay? But then when I look through this, it's not really clear to me where my code is. So I look through this and I don't know where it is. My code must be down here somewhere. And then, it's not here because this is an event loop, right? So it ran my code, but I don't know what my code is. Now, some reactive APIs do have ways where you can create markers so that you actually get better stack traces, but it's still not quite good. Right. So that was your brief overview of Reactive. So let's talk a little bit about where we are with JDK Project Loom virtual threads. So in 2023, last year, Project Loom produced the first bit of fruit, which is, of course, the virtual threads. But let's talk a little bit about that project in general, right? So it's actually not just virtual threads. The entire project, which is called Loom, is fibers, continuations, and tail calls for the JVM. Okay. So when I read this, I'm like, okay, well, I've heard fiber before, right? And that's basically just the name for a lightweight thread. So we changed fibers to virtual thread, right? And a continuation is an important part of this. So this is kind of hidden from us when we use a virtual thread API. But essentially, it's a continuation or coroutine, which Kotlin has, right? And basically, it's some sequence of instructions that can yield and be resumed to the caller at a later stage, right? So basically, it's the ability to take your code, run it, and then pause it, right? And that's basically the idea. But that's actually built into the JVM at a lower level that you don't really see in your own code. And tail call optimization hasn't actually been implemented yet. And that's really just the idea that when you have a recursive function that calls itself, you can actually turn it into a non-recursive loop at the compiler level as an optimization. So that's sort of the story there. So, of course, we have the first one, virtual threads. And the reason this talk has said JDK 19 is because virtual threads have been available since then, right? But JDK 21, which is last year, was the first version that they're final, they weren't in a preview mode under a flag or anything, okay? And fortunately, JDK 21 is an LTS release, which means people will actually use it. So it's a good deal. And by the way, JDK 22 is out, if you didn't know. So which means you should be able to use JDK 22 and 21. So if you need justification where people say, oh, 21's too new, you can say 22 is out. So structured concurrency is in the second preview in JDK 22. It's basically the same preview in JDK 21. And I'm not going to go into structured concurrency too much, but basically it allows you to simplify a lot of the programming that you need to do that may involve multiple threads beyond the initial request. So the initial request comes into your service, right? And that may be a virtual thread, you're happy. But what if you actually need to do some work that spawns other threads, right? You can use completable futures, right? Or you can use reactive APIs. Or with structured concurrency, you can write this stuff in a very sort of sequential, imperative-looking way, and it ends up running in different virtual threads. So that's a new one to look for. And scope values basically allows you to manage sharing of immutable data across child frames in the same thread and with child threads. So it's basically a replacement to handle some of the limitations that virtual threads have, which we'll talk about in a minute. Okay, so Loom was started in 2017. The first preview shipped in JDK 19, which is fall 22. The final version came out in 21. I'm sorry, in JDK 21 in 2023. And the key thing is that virtual threads give you end-to-end scheduling, right? So you have n number of virtual threads that map to n number of platform threads. So we have access to many more than just one thread now. You can have lots of different cores. So, and the way this works is like this. Let's see if we can zoom this in a little bit. Okay. So the key thing here is, just like read threads, there's now a JDK scheduler, right? So the JDK actually does the scheduling for the virtual threads. And it can create a lot of virtual threads. They're very cheap to create. It can create a whole bunch of them. And it may have a whole bunch that are just hanging out waiting to be used. And they can be attached to platform threads. And each platform thread can carry one virtual thread at a time, because obviously when it's carrying it, it's using it, right? And they refer to the platform threads as carrier threads because they carry a virtual thread. So basically what happens is over time, the virtual threads will be given to a platform thread. And then whenever they block or they complete, they will be taken away from the platform thread, and then another virtual thread will be added. Now, what can happen is they can block, right? So whenever this blocked for some reason, you talk about the situations where that can happen, we have what's called pinning, right? And pinning is basically saying that you have now pinned your virtual thread to this platform thread, and we cannot move it away until you unpin it. And pinning happens when you hit a synchronized block, call a native method, or you call a native method or a foreign function. So those are the two basic ways. Okay. So the synchronized keyword is not a happy thing for virtual threads. So the antidote for synchronized blocks is to use the reentrant lock. So if you use that instead of synchronized blocks, you can avoid pinning threads. And of course, if you have native calls, you can, there's the new foreign functions API, which you can use instead of JNI. Oh, I'm sorry. I'm looking at my screen. My screen looks funny. All right. Sorry about that. Okay. Excuse me. There. I'll talk more about this later, but there's a handy option you can use called JDK trace pin threads, which will tell you if there are pin threads in your application. So this will be very useful to use if you do indeed embark on the virtual thread journey. So another thing you need to do or keep in mind is that you can't really pull virtual threads. So you can't like create your own little thread pool and pull them, because the reason you pull threads is because they're an expensive resource, right? Because threads are expensive. You only have a certain number that you want to manage at one point in time. So we create pools. But with virtual threads, they're not expensive. They're cheap. And pooling is sort of antithetical to the way they work. So the idea is that you can create as many threads as you want, and JDK scheduler will take care of like applying them to real platform threads. Okay. You also want to avoid long-running actions in a virtual thread. So if you have something that takes 5 minutes to complete, well, probably not the best thing for a virtual thread. Because what's going to happen is the JDK is going to be sitting there like thinking that it can use that thread to do other things, and it's going to create more virtual threads. You basically are monopolizing a thread. So you want to avoid that. And the other issue are thread local variables. So you can't use them to cache or pull expensive, mutable, non-thread safe objects. And that's generally what people can, there's different ways to use them. You can use a thread local for a single variable just fine. But if you're trying to use it as a pool to cache objects, that won't work, because the thread local will belong to that one virtual thread, right? And then if you create another virtual thread, you'll get a copy of it. So if you're okay with wasting memory for a whole bunch of objects, that's cool, but it's not like they're all going to be sharing the same pool. So So, because what we're used to is our code sort of moves around from, one thread to like a small number of threads that may have a, right? But that's not the case here. So scope values is an alternative for virtual threads. For thread local variables. So if you wanted to actually create virtual threads yourself manually, this is what you would do. And it's strikingly similar to what you would do with normal code. So haven't people used the thread API before? Anybody? Okay, so a few. It's very simple. But basically, right now, you can actually create a new thread object, but you usually use an executor or an executor service, and they'll create a thread for you. And they will create a thread pool, but we don't really need to create pools, right? So basically, you can use an executor, and you can call a new virtual thread per task executor. And then once you do that, you can submit something, and this basically creates a new thread for you. So, and this is a standard Java API, the executor API. There's nothing special about it. This is just a special virtual thread version of it. Okay. You can also create a thread this way with thread of virtual or start virtual thread. Very readable, right? And anytime you have a thread, you can just ask it, are you virtual? And find out. Okay. So this is one of the nicest things about the way this is done. It's integrated into the way that normal Java programming is done, right? And by default, all the old code still works the way it used to. But if you swap in a virtual thread executor, magically you get virtual threads. So I do think it's worth pointing out that in order to do this work, it was non-trivial. And a lot of the times, us as consumers of Java technologies, we're like, oh, why did it take so long to add this feature? Like all these other languages did it like 10 years ago. But we don't always think about, what goes on to do things, right? So I just wanted to point out that a lot of things happen in order to make virtual threads possible. Remember, Java is like 25 years old or more. So a lot of these things weren't built with the idea of there would be this whole new virtual thread thing in mind. So over the years, they have been steadily refactoring things to support virtual threads. And we didn't even notice. Everything just continued to work, right? So the thread API, of course, had to be reworked. Java Util Concurrent, JavaNet, Java NIO. So all of these sort of had to be rebuilt, or not rebuilt, but some refactoring for virtual threads. They also updated the debugging tools. I also should mention, I don't think I have an example of it, but the stack traces even show virtual threads too, right? So all basically it's a very seamless experience. And over the years, there have been several other Java enhancement proposals, JEPs, that have been used over the years. So one is re-implement core reflection and method handles. That was in JDK 18. That removed VN native reflection implementations. So that was important. There was a re-implement legacy socket API in JDK 13, and that allowed us to replace the implementations of the socket, server socket datagram with implementations designed for use with virtual threads. Internet address resolution, SPI, in JDK 18. To handle some issues that third-party libraries or that there might be with internet lookup addresses. So just keep in mind, this didn't happen overnight. It took a long time to build out this feature set and make sure we had a very stable platform for moving forward. Okay, so that's all fine and dandy. So how can I actually use this and does it work, right? So that's usually the important side of things. So if you start with sort of the lower level, if you look at like the actual web servers or server API servers, you can actually turn on virtual threads today. In Apache Tomcat 10.11 and higher, you can just configure the standard virtual thread executor. And this is something you would do if you're using Spring Boot. There's a different way to do it. If you're using Tomcat by itself, this is a way to do it. Okay. Yeah. And you notice this is really the only thing. And what this does is it makes sure that every time you have a request coming into your servlet, it will get a virtual thread, right? Which is essentially the main thing, right? So Jetty has support as well. And if you're creating Jetty programmatically, you need to use this new virtual thread per task executor, right? So you just set that up directly when you create Jetty programmatically. If you're using configuration, there is a thread pool module that needs to be added. And that's pretty much it. And again, if you're using it embedded with Spring Boot or something, there's a different way to do it. So, Netty, of course, does not really support this stuff because it's not really, the same. It's not really logical for them to do so, to tell you the truth. So there's, of course, a thread about doing it, and they are like, yeah, whatever. So Undertow, which is another server engine, I haven't seen anything about virtual threads for them. If you are using a microservice framework, Quarkus has built-in support. How many people saw Daniel O's session earlier? Okay, so a couple of you. So he went more into detail about Quarkus, but they do support virtual threads, and the performance is almost as good as the Reactive, not quite, but it's pretty close. And what's interesting is that they've done a lot of research on this, probably the most that I've seen from any vendor. And what they recommend is using Quarkus REST and the Quarkus Reactive extensions, because basically what they've seen is not every third-party library supports that, and we'll talk about it later. So they encourage you to sort of mix and match it. Quarkus makes it really easy. So they basically just give you an annotation. They're like, okay, you write your service the way you normally do. This is a normal Quarkus service that uses Jakarta Rust. And you just add this run on a virtual thread annotation. So they're taking more of an opt-in approach where, you leave your code the way it is, but if you want to use virtual threads, you use this annotation, and then it'll run it on a virtual thread for you. Okay.
Done.
So Quarkus actually has some good virtual thread demos, which is handy. So if you're interested in that, you can check those out. So I think I saw one Helidon user somewhere. So was there a Helidon user? Helidon? Oh, it was Micronaut. Oh, there is a Helidon user. Yes. All right. So Helidon is a microservice framework from Oracle. And what's interesting about what they did is they were using Netty for their reactive stuff. And what they did was they wrote an entirely new web server from the ground up using virtual threads. They said they got rid of a ton of code. And so as a result, it's probably the only microservice framework where it's like totally, rewritten from the ground up to really work well with virtual threads, which you would kind of expect from Oracle. So they've got some information about that. But they were apparently very pleased with the process of writing their new server, which is called Lima. So cool.
Yeah.
And Micronaut has support as well. I don't think I have an example for it, but they do have support in Micronaut 4 and higher. So for Spring Boot, how many people are using 3.2 or lower? Just out of curiosity. No, not that many of you. Okay, so okay. Well, if you're using, 3.1 or lower. If you're using an older version, 3.1 or lower, you have to sort of manually do a little bit of work. And it's not a lot of work. You basically just have to set up the task executors to be virtual thread ones. So again, there's that new virtual thread per task executor, right? So this is for async tasks. So for any background tasks you have running, you want to use it. And then for Tomcat, if you're using Tomcat, and I believe if you're using Jetty, you do the same thing. So you just got to do a little bit of work there, but then you'll get basic support. If you're using 3.2 or higher, they built in the virtual thread support. So there's a couple of application parameters. One, which is virtual threads enabled equals true. Makes sense. And another one they have, which is kind of interesting. And this is actually a little bit newer. So they have this Spring main keep alive equals true. And I saw that. I'm like, what is that? So basically, one of the nuances of virtual threads is that if there are virtual threads running but no platform threads, then the JVM will exit. So basically, virtual threads are basically daemon threads. So in order to make sure that if you only have virtual threads running, the JVM continues to execute, you need to turn this feature on. And that could happen if you have something that's just waiting for tasks to occur or something, right? So if you want to read about it, there's more information there. If you're using Jakarta, anyone using Jakarta? All right, so a few of you. So for that, there's, and I work with Jakarta a decent amount, and I couldn't find any vendor saying any details about virtual threads, about exactly how to turn it on or, what their deal is. So you'll have to look at the docs for your particular product. Obviously, if they're using Tomcat or Jetty, then you can just do it that way. But mostly it's an implementation detail. However, if you're using the Jakarta concurrency utilities, and basically what they do is they give you managed versions of all the concurrency primitives. They are adding support for that, for virtual threads for that in Jakarta E11, which should be out this year. So for that level, they're adding, for the programmatic support, they're adding, but in terms of just getting the runtime to just run your code using a virtual thread, that's going to be a configuration level thing at your application server level. So, okay, so nothing is perfect. So what are the drawbacks? So we talked about a few of them, right? One is pinning, which can happen if you synchronize block or use native calls. We talked about monopolization, which can happen if your virtual thread is consuming a platform thread for a long amount of time. We talked about using thread locals for caching, which can be a problem because, remember, there can be thousands and thousands of virtual threads. So caching is going to be prohibitive in some cases. So those are things you need to worry about if you're writing code. But you also need to worry about that in your third-party libraries because, let's face it, we work with like mounds of code that other people wrote. It's sort of like, this bottle, right? There's all this water in here. This is like all the code you use, and this is like your code. There's your code. Here's all the other code. All right. So you need to think about the libraries that you're using and what their story is. And this is really the issue with virtual threads is that they're new, right? If you even look back to the first preview release that came out, less than 3 years ago. So there's libraries you don't think about. Like the first one that I was surprised to hear about was Jackson. Jackson's a very popular library used for JSON serialization and processing, right? And they added an SPI that runtimes can use for virtual threads. So that sort of put the onus on the runtimes to do stuff. And it's still not clear to me to this day whether, like, if you get raw Jackson, whether it supports virtual threads. If you use Jackson, like with Quarkus or maybe with Spring, it might work. So it definitely works with Quarkus. I'm pretty sure it works with Spring as well. But that's something to keep in mind. Do I need to use a different JSON processing engine, or is Jackson fine? And I started thinking about, okay, what other libraries might people be using? Anyone using OpenTelemetry? Nobody. Wow. Yeah. Anyway, so their stuff works, but they had like a bug in one case. If you turned on this flag, which I told you to turn on, it like crashes the VM or locks it up or something, which is fun. Database drivers are important. Fortunately, they all seem to, for the most part, had support, but you'll have to make sure you have the right version, right? So Postgres added it in March. Oracle added it a long time ago because they knew about virtual threads. Mongo added it last year. And, whatever other drivers you're using, you'll have to see if they support it. I looked up SQL Server. I saw nothing, which is too bad. And so that's one thing. this is actually a very good blog post, even if you don't use Quarkus, just about the different libraries and issues with virtual threads. So I encourage you to check it out. And of course, we said using this JDK trace pin threads feature is a great idea. I didn't add it to the logs, but I didn't add it to the slides, but Log4j had issues too. So I looked through Log4j, and they're using synchronize in a few places, and those aren't fixed until Log4j 3, which is in beta. So if you use Log4j, you may end up in a situation where it's hitting a thread. So this is why I think, if you're really interested in doing this, set it up, get it running, run your tests, use this trace pin threads and see what you can find, and if there's any major issues that need to be handled. All right, so and with that, you can find me on the web there, and thank you very much.